Hello 8th grade Grizzlies, this is Miss Brown and this is a review for your chemistry test, which is on Wednesday, March 27th. Okay, so there's two parts to this chemistry unit that we started. Okay, so we started off talking about chemical and physical changes, and then we went into atomic structure. So the first part of this video is going to be a review of physical and chemical changes. And then the second part of the video, we're going to go over the atom. So the parts of the atom, how to find the atomic number, protons, neutrons, electrons, and how to do Bohr models. So let's get started. All right. Let me adjust my camera here. Okay, sorry about that, ladies and gentlemen. I just wanted to adjust the focus. Okay, so we started talking about physical, talked about physical change, and then we also talked about a chemical change. All right, so the definition of a physical change is any change in the size, shape, or location. Okay, so some examples of physical change is a phase change. And by phase change, I mean solid, liquid, or gas. Okay? So a good example of this is water. Okay? The solid form of water is ice. Okay? Then we all know that the liquid form is fluid, and then the gas form of water is steam. Okay, so it's all still water, it's just in different phases. So when it's solid, it's ice. When it's liquid, it's flowing, and when it's gas, it's steam. Okay, some other examples of physical changes are cutting, tearing, dissolving, and shredding, just to name a few. So basically, if something has undergone a physical change, it is still the same object or same substance. It's just that you've changed the size, shape, or location. Okay? Another example is this pencil. Okay? If I break this pencil in half, it's still a pencil. I've just changed the size. I've made it smaller. Okay? All right, chemical change. Okay, these are changes that alter or change the chemical makeup of a substance. Okay, so some examples of things that are chemical change. Anytime you burn something, that is a chemical change. So wood, if you burn wood, it becomes ash. You can't take that ash and make wood. That's a chemical change. An example is metal that rusts. Metal is one substance. If it rusts, rust is a totally new substance. Okay? The big thing you need to know for your test, hint, hint, is that a new substance is formed in a chemical change. Okay? An example is a really good example is a glow stick. Okay, so in the glow stick there's a tube with liquid, and then there's another tube inside of the first tube that has another liquid. When you break the tubes, those liquids mix and it gives off a color. Okay, so you get a color change. Okay, another example of a chemical change is eating. Okay, so when you put that apple in your mouth, for example, you put the apple in your mouth, you chew it, it's undergoing a physical change because you're breaking into smaller parts. But once your body digests that apple and it comes out as solid waste, it is no longer an apple. It has undergone a chemical change. Okay, so you do have a question on your test that asks which one is a chemical change. So anytime you burn, digest, eating, or you get a completely new substance that is different from the original, that would be a chemical change. All right, I'm going to pause here and we're going to go into atomic structure. Okay, so we're going to start with the atomic structure portion of this review. Okay, so I'm actually going to draw this out. All right. All right, so we talked about the structure of an atom. Okay, so an atom is made up of two parts. Okay, there's two parts, and then there are three subatomic particles. Okay, so there's two parts to the atom. Part one is the nucleus. Okay, let me spell that correctly. And the other part is the electron cloud. And we also call the electron cloud energy levels or electron shells. I'm going to use energy levels. Okay. All right, so this part of the atom is the nucleus. Okay, that is the center of the atom. Okay, the nucleus is positive. And it's a positive charge of however many protons are in the nucleus. And I'll show you that in a second. Okay, and the majority of the mass is here. Okay. All right, so within the nucleus, we have the protons, which are positive, and we have the neutrons, which have no charge. Okay, so those are my protons, and these are my neutrons. So the charge of the nucleus of this atom, the charge of the nucleus is positive, and then whatever my protons, so 6. Okay. Okay, the second part of the nucleus are the energy levels. Okay? These are the rings around the nucleus. Okay? And the electrons are here. Okay? So if we're going to build, we're going to put in our electrons to draw out this atom. So these are the energy levels. Okay? So my electrons would go here. So I have 2 in the first energy level. So I'm going to have 6 because I have 6 protons. And then the other 4 go in the second energy level. And we're going to practice this. I'm just drawing it out so since we're talking about the structure of an atom. Okay? All right, now let's talk about the subatomic particles. So we have the proton, the neutron, and we have the electron. Okay? Protons are positive. They are in the nucleus. Okay? Then we have the neutron, which has no charge. And when I draw them out, I'm going to use a circle with a line through it. And they are also in the nucleus. Okay? The proton and the neutron are about the same size. Okay? And these 2 particles in the nucleus give the atom its mass. Okay? All right, on to the electron. Electrons are negative. They are in the energy levels. And compared to a proton and a neutron, they have little to no mass. Okay? So when you see an atomic mass that's like, let's say 14.2, the decimal is usually the mass of the electrons. I just say that to say they have little to no mass. So compared to a proton, electrons are very small. Okay? All right, let's go over the 2 acronyms that we learned, the rules for Bohr models, and then we're going to draw out some Bohr models. Okay? So the first thing we learned was A equals P equals E. So that means your atomic number tells you the number of protons, and it tells you the number of electrons. So if you are looking at your periodic table, if I want to know the number of protons in fluorine, we look at the atomic number is 9, means it has 9 protons. Bromine, atomic number is 35, so that means it has 35 protons, 35 electrons. If I want to know the number of protons for copper, atomic number is 29, so it has 29 protons, 29 electrons. Okay? If you get stuck, ladies and gentlemen, you can look at this example on your periodic table. It labels everything for you. So your atomic number tells you your protons and electrons, and this is the mass. So that's all the stuff in the center of the atom. Okay. And then the other acronym we learned was MAN. So your mass, which is the decimal number, which we'll round up or down, minus your atomic number, gives you your number of neutrons. Okay? so for example, I drew out the little box for carbon. This is your atomic number, which equals your protons, which are positive, and your electrons, which are negative. Then to get your neutrons, you would do your mass, 12, minus your protons, gives you your neutrons. All right. Okay, the last thing we need to go over is the rules for Bohr models, and then we're going to practice drawing Bohr models. Okay? So this is your nucleus, and only protons and neutrons go there. These are your energy levels. So when you place your electrons, you can only have 2 in the first energy level, up to 8 in the second, and up to 8 in the third. You must follow those rules. And at the end of this video, I'm going to show you a couple of examples that don't follow those rules. Okay? Okay, so now we're going to practice Bohr models. Okay, so basically what I'm going to do is pick like 4 or 5 elements. We're going to draw out the Bohr model. Okay, if you follow this format, and I know it's going to seem redundant, I'm writing the same thing over and over, but if you do this, you'll get the answer correct. Okay, so we'll start off by drawing atomic number equals protons equals electrons, and then mass minus atomic number equals the neutrons, and then we're also going to put the charge of the nucleus. Okay, so the first element we're going to do is lithium. So lithium is right here. It has an atomic number of 3. So my atomic number is 3. That means I have 3 protons that are positive and 3 electrons which are negative. Okay, your mass is 6.9, so we round that to 7. So my mass is 7 minus my atomic number, which is 3, gives me 4 neutrons. Okay. Now the charge of the nucleus. The nucleus is always positive plus the number of protons. The charge is positive, and then the number would be the protons. Okay, so the charge of your nucleus is plus 3. Okay.
Mom.
Okay, let's draw out our Bohr model. So I'm going to show you 2 ways to draw this, the long way and the short way. We're going to do the long way on this one, and we'll do the short way on the bigger elements, okay? All right, so protons. I have 3. Protons are positive. Neutrons go in the nucleus. I have 4. They have no charge. I have 3 total electrons. So I can put 2 in the first energy level. And I have 1 left, so that's going to go in the second energy level. And that is my Bohr model of lithium. Okay. All right. Next one we're going to do is aluminum. So let's write it out. Atomic number equals protons equals electrons. Mass minus atomic number gives you neutrons. And we're going to do the charge of the nucleus. Okay. All right, let's look at aluminum right here. It has an atomic number of 13. So that means I have 13 protons, 13 electrons. My mass is going to be 26.9. We're going to round that to 27. So my mass is 27 minus my atomic number of 13. I'm going to have 14 neutrons. Okay. The charge of my nucleus is positive, and that positive number is going to be my protons, which is 13. All right. Now we're going to show you the short version of how to draw this out. So I'm going to draw my nucleus. I have 13 protons, so we can do P equals 13 and put that plus sign. My neutrons is 14, and I'm going to do a circle with a line through it because it has no charge. Now I have 13 electrons. We got to do the 288 rule. So in my first energy level, I can put 2. Okay. Now you don't have to do this for the electrons. This is just something I do. It helps me to keep track of where they are. Okay. Now I can put 8 in the second. Okay. And I do them in pairs. You don't have to. Okay, so I have 8 in the second, which leaves me with 3 because I have 13 total. So I have to draw another energy level. 1, 2, 3, and there's my Bohr model of aluminum. All right, let's do another one. Let's do nitrogen. So I'm going to write out A equals P equals E. Mass minus atomic number gives me neutrons. And charge, excuse me, of the nucleus. All right, so let's look at nitrogen. It has atomic number of 7, and it has a mass of 14.0, so we're just going to keep it at 14. So if my atomic number is 7, I have 7 protons and 7 electrons. My mass we said is 14, minus my atomic number gives me 7 neutrons. My nucleus is always positive, and it's the number, that positive number is the number of protons, which is 7. So let's draw it out. We're going to draw out the long version this time. Okay? So I have 7 protons. 1, 2, 3, 4, 5, 6, 7. I have 7 neutrons. 1, 2, 3, 4, 5, 6, 7. Now I have 7 electrons. I can put 2 in the first energy level. 1, 2. So I have 5 left. I can put up to 8 in the second. Well, I only have 5, so those other 5 are going to go in the second energy level. Oops, whoops, I forgot to draw my energy level. Oh, hold on, guys. I forgot to draw another energy level. Okay, so this is my first energy level. Here's my second. 1, 2, 3, 4, 5. There we go. Okay, so 2, 3, 4, 5, 6, 7. Okay. All right, let's do one more, and then we'll go over Bohr models. I want to show you something you might see on your test, and then we'll be done. All right, so let's do chlorine. So your atomic number equals your protons equals your electrons. Your mass minus atomic number equals neutrons. And let's do the charge of the nucleus. Okay, so chlorine. Chlorine has an atomic number of 17 and a mass of 35.4. We're going to keep it at 35. So, atomic number 17, which means I have 17 protons, 17 electrons. To get my neutrons, I'm going to do my mass, which I said was 35, minus my atomic number, gives me neutrons. The nucleus is always positive, and it's going to be 17 because I have 17 protons. All right, let's draw it out, and we're going to do the short version because this is a pretty big atom. So, 17 protons, 18 neutrons. Okay. Now we have 17 electrons, and we've got to do the 288 rule. So we can do 2 in the first energy level. Okay, so I have 15 left to place. I can put up to 8 in the second energy level. So 1, 2, 3, 4, 5, 6, 7, 8. Okay? So I can put up to 8 in the second. Now I have 7 electrons left. I can put 8 in the third energy level. So I'm going to draw another energy level, and I can put up to 8. So I'll put 7 in the third. So 1, 2, 3, 4, 5, 6, 7. And that is a Bohr model of chlorine. Okay, I'm going to pause for just a minute. I'm going to show you an example of one of your test questions, and then we will be done. Okay, this is the last thing I want to go over with you. Is you're going to see something on your test that looks like this. Okay? Now, it's going to ask you which of these models is correct for carbon. Okay? Well, let's look at carbon. Carbon has an atomic number of 6 and a mass of 12. Okay? So let's come up here to the top. So your atomic number equals protons equals electrons. So if your atomic number is 6, that means I have to have 6 protons, 6 electrons. We said the mass was 12. So 12 minus my atomic number gives me my neutrons. Okay? So basically now what I need to do is look at each of these models. Not only do I have to make sure the number of protons, neutrons, and electrons is correct, I need to make sure that my electrons are placed in the correct places in my energy levels. Okay? So let's look at the first one. I have 1, 2, 3, 4, 5, 6 electrons. Okay, that's good. I have 1, 2, 3, 4 protons. Okay, this can't be correct because number 1, carbon has to have an atomic number of 6, which means it has to have 6 protons. I only have 4. This isn't carbon because remember, protons determines the identity of the element. So this would not be carbon because of the number of protons. The other thing that's wrong is I have 4 electrons in my first energy level. I can only have 2. So this is wrong. So let's go over to this one. I have 1, 2, 3 protons. This is automatically wrong. Carbon has to have an atomic number of 6, has to have 6 protons. This only has 3. So that's gone. So let's look at these two. So I have 1, 2, 3, 4, 5, 6 protons. I should have 6 neutrons, which are green. So I've got 6 neutrons. And I have 1, 2, 3, 4, 5, 6 electrons. Now, I have 2 in the first energy level, which is correct. I can have up to 8 in the second, and I have 4. So this is a possibility. Let's look at this one. And I'm going to have to zoom in. So I have 1, 2, 3, 4, 5, 6 protons. I have 1, 2, 3, 4, 5, 6 neutrons. And I have 1, 2, 3, 4, 5, 6 electrons. Okay, however, my electrons are not placed properly. I have 5 in the first energy level. You can only have 2 in the first and 8 in the second. So while my numbers here are correct, the model is drawn incorrectly. So my answer would be this one. Okay? You will see this question on your test. So there's a freebie for you. Okay, that concludes this review video. So on behalf of Ms. Ludeman, Mr. Winter, Ms. Ford, and Ms. Smith, go Grizzlies, and we know you're going to do well.